with a plot of revelation of one of the difficult problems of advanced statistics and probability. My name is Ahsan Ahmed and I am a mechanical engineer. The idea behind working on this title is to help students and researchers to get the solution of most brainstorming problems of advanced statistics and probability, whose solutions are either not available or they have some price. And believe me, I don't want to pay the price. Now let's move forward to the problem. The energy demand of a certain city remains in excess of 8,000 megawatt for 20% of time and less than 4,000 megawatt for 15% of time. Determine the mean energy demand and variance if the demand follows normal distribution. Now, first we have to analyze the given problem. First condition: the energy demand of a certain city remains in excess of 8,000 megawatt for 20% of time. It means we have to find the probability, or we have to find the occurrence of the occurrences whose probability is 20% time that the occurrences are more than 8,000 megawatt. You can see in this dome of normal probability curve that the probability of exceeding 8,000 megawatt is given, that is 20%. Now move forward. Second condition: the energy demand of a certain city remains less than 4,000 megawatt for 15% of time. You can see in this image that it means that the probability that x is less than 4,000 megawatt is given, that is 15%. Now, by the help of these two conditions, we have to find out mean energy demand and the variance. This is the requirement of the problem, which I told you before, that we have to find out mean energy demand and the variance, mu and sequence square. According to the first condition, x is greater than 8,000 megawatt, 20% of the time. So the corresponding value of z will be z equals 8,000 minus mu over sigma. It comes from z equals to x minus u over sigma, and here is our z and here is our x. Now, since probability of x is given, x greater than 8,000 megawatt, in the z form it can be expressed as this expression, and this equation can be finally reduced to 0.20 equals to 1 minus p of z less than 8,000 minus mu of sigma. By solving this, we can get this. The probability of z, which is less than 8,000 megawatt minus mu over sigma, equals 0.0. Now we have to use the z table to find the value of z against the probability 0.2, and we find it to be 0.84. Now by solving this for mu, we get this equation, which I named as equation 1. Now from the second condition, which is p of x, probability of x less than 4,000 megawatt is 15%. So the corresponding value of z will be z equals 4,000 minus mu over sigma, as we did for the first condition. So P of X less than 4000 megawatt equals to, in condition of the Z, equals to P of Z less than 4000 minus mu of sigma, which can be equal to this. Now from the Z table again, we find out the value of Z against the probability of 0.15, which I found to be minus 1.04. Now by solving for mu, we get mu equals 4000 plus 1.04 sigma, which I named as equation 2. Now by substituting equation 1 in equation 2, we get this equation. Sorry, uh, I drew a very large area. This is the equation. Now by solving this equation, we can find the value of sigma, that is our standard deviation, which I found to be 2127.66 megawatt. Now with the help of this, we can find mu by putting the value of sigma in equation 2. We get mean energy demand, which is mu is equal to u 6.22 62212.7 megawatt, and now variance can be found by squaring simply the standard deviation. So here are the requirements of the problem. Thank you, and if you like this video, please uh, check the like button and share it to your friends. Thank you.